So let's solve this problem together. So as we can see here that this non-negativity constraint is missing, meaning that we have to solve it in some other way. So let's first make a Tucker tableau. So first we will circle the unconstrained variables, which are x and y here. And now we can choose a pivot. So now in the lecture notes, Professor chose this to be the pivot. The reasoning was that choosing this makes our calculations a lot easier and our values will stay in integer form, so we won't have fractions. But I will be solving by using this pivot, so it's more clear. So by the pivot transformation algorithm that we did in lecture 7, this is how we can calculate all these values. So this is the values that we need. So if we see, okay, for the first table, so our pivot here is -3. The value for R is -1, and C is 1, and S is 3. Now if we transform this, so pivot will be 1 over P, which is 1 over -3. So -1 over 3. This will also be -1 over -3. So this will be positive 1 over 3. This is -c over P. So -1 over -3. So positive 1 over 3. And this one is, so P times S, so -3 times 3 minus R times C, minus R times C over P, which is -3. So we will get positive 8 over 3. Now we can fill in the values here. Now for these two values, so pivot will remain the same. R will become -15, C will be 1, and S will be 0. So we can fill the table now. So now we can fill the tableau. Now for the values above the pivot, so -3 is the same, and then C will be the one on top of the pivot, so 1, and R will be 1 beside it, so -1, and S will be the diagonal value to the pivot, which is 2. Now for the remaining value, so -3 is the pivot, and C is 1, and R is -15, and S is 10. Now let's solve it. So here also we got positive 5. Now that we have the equation for -x, we can record it. Now for the next iteration, we will delete this row. So we will be deleting this row. So now we have rewritten the table without this row. Now we can choose the second pivot here. So let's circle our unrestricted variables. Now we can select the pivot. So this is the only pivot we can choose now. So let's do the same process that we just did by using the pivot rule algorithm. So this is a tableau that we will get. Now we can write the equation for negative y. And now we will delete this row. Okay, so this is the final table that we got. So now we will check if there are any main constraints left. As we can see, there are no main constraints here. And also the function has reached to its optimal solution. We can see that these both values are negative, meaning that we have reached to the optimal solution. Now the third and final step is to plug in the values of t1 and t0 at zeros in these two equations. So now let's do that. So as we can see here, these are the values we got for x and y. So I got this value from the table here. So the values for x and y is 4 and 3. And the objective value is 13. And t1 and t2 are 0.